This is a video lecture for Math 140 for Thursday, April 30th. And the topic today is the circle. This is part one of the video lecture. We're getting into a new chapter now. And we're going to be talking about the circle, which is actually one example of a conic section. There actually are four conic sections, and they are the circle, the ellipse, the parabola, and the hyperbola. And these are called conic sections because these shapes are created by taking planar cuts through a right circular cone. And let me show you guys, instead of my drawing that, because it's kind of a tricky drawing to do, I'm going to show you guys what I mean by this. So this is an image here, and we have a right circular cone. And these different shapes are created by taking different planar cuts through that right circular cone at different angles. So a circle is a cut, is basically a horizontal, purely horizontal cut. An ellipse is a cut where you go at an angle. And then if you go at a steeper angle, you get a parabola. And then if you make a vertical cut, you actually get a hyperbola. So those are the conic sections. When we put the camera back here, I'll show it to you guys one more time if you can get a good view of that. And today specifically, we're going to be talking about the circle. And the definition of a circle, let's talk about the definition, is the set of all points that lie in a plane that are equidistant from a fixed point, and that fixed point is known as the center. So let me step back from this. The definition of a circle is the set of all points in a plane that are equidistant from some fixed point. And what we're going to do now is we're going to derive the equation of a circle. Okay, and this circle we're going to assume has a center at HK. This is the center of our circle. This is some point on a coordinate axis grid. And we're going to also assume it has a radius that's equal to r. Okay, and finally, we're going to consider the point xy to be any point on the circle. Okay, and we can now draw a diagram of this so we can see visually better what's going on. So if I have a coordinate axis grid here, if we have some circle located like this, okay, we have a center here. This center is the point HK. And r is the radius. In other words, r is the distance from any point along the circle to the center. And then we can represent any point on this circle as being the point xy. And now we want to derive an equation for our circle. And what we're going to use is the distance formula between 2 points. I think we've talked about this formula before in this class. I'm not exactly sure. But if you have 2 points and you want to find the distance between those 2 points on a coordinate grid, this is the equation we use, where the 2 points we're interested in are x1, y1, and x2, y2. So this formula gives the distance between these 2 points. So we're going to apply this formula to our circle. Let's find the distance between the center HK and the point xy. So if we apply this to those 2 points, so let's just write this, the distance between the center HK and the point xy. Okay, if we use our distance formula, then d, the distance between those 2 points. Now note that the distance between these 2 points is exactly r, right? That's what defines the radius of a circle. It's the distance between the center to any point on the circle. So we know the distance between these 2 points has to be r. And now if we plug in this equation, we get x minus h. So I'm going to take the point xy to be x2, y2, our second point, and the point hk to be our first point. We get x minus h squared plus y minus k squared. Okay, this is just using the distance formula to find the distance between the center and the point xy. And then what we can do is we can square both sides of this equation. And if we do that, if we square both sides, we get r squared equals the square of a square root is just the thing itself, equals x minus h squared plus y minus k squared. And let me box this. This got kind of low to the bottom of the board here, but let me box this. This is the equation of a circle, and this equation, this form is known as the factored form. This is the factored form of the equation of a circle. There's actually another version of the equation of the circle we'll talk about in the second part of this video. And this is for a circle with a center of hk and a radius that equals r. Okay, this is the equation of a circle in factored form with a center hk and a radius r. Okay, so this gives us all the points x, y along our circle. Now, one thing I want to talk about, let me just erase this top part, but I'll keep this bottom part. One thing I want to talk about is what this hk means for a circle. If you have, so a circle with a center at 0, 0, right, is a circle with a center at the origin. So if h equals 0 and k equals 0, then the circle is centered at the origin. And then if you have a circle with a center h and k, that means that that's a shifted. So if you have a center hk for your circle, that means the center is shifted h units horizontally, and it's shifted k units vertically. So h and k tell you the amount the circle is shifted horizontally and vertically from a circle that's centered at the origin. So if h equals 0 and k equals 0, your circle is at the origin. For a center hk, that circle is shifted by an amount h horizontally and k vertically from the circle centered at the origin. And keep in mind, the direction of the shift is opposite to the sign. And so if h is positive, that means your circle has shifted to the right. And if k is positive, that means your circle has shifted up. So anyway, just keep that in mind. The shift is opposite to the sign. Okay, in the second part of the video lecture, we're going to do 3 example problems involving circles.